Good evening, good afternoon, good morning, and a happy Thursday. Ladies and gentlemen, welcome to the second Marintec Innovation Webinar Series. I'm Jingbao Wang, Deputy Director of Shanghai SNAMI, also Chairman of ITDC Specialist Committee on Ships Operational Performance. It's my pleasure to moderate the second webinar in its series, focusing on zero carbon emission, keeping a watchful eye on the fourth industrial revolution at sea. Hopefully, this webinar will introduce some new insights and ideas on the innovative technologies from the maritime world today. Today's keynote speaker, Dr. Martin Stoffel, Non-Executive President from Clarkson Research Services, will bring his latest research findings and viewpoints to this webinar and explore the way of zero emission in shipping industry. Hi, Dr. Martin. Would you please say hello to our audience?
Well, good evening, Dr. Wang, and good evening or good morning to everybody who's listening. It's a great privilege and a pleasure to be here, and thank you for the opportunity to talk to you this afternoon or this evening.
Thank you, Martin. Martin is joined by three eminent panelists from the maritime technology world. Tom Strong, Senior Vice President of Carnival Corporation from Maritime Affairs. Hi, Mr. Tom Strong.
Yes, good afternoon, good evening, Dr. Wang, and everybody else. It's my pleasure to be here, and thank you very much for inviting me.
Thank you, Mr. Tom. The second is Mr. Luo Xiaofeng, Director from CCS, China Classification Society. Hi, Mr. Luo.
Hi. Good day, everyone. My pleasure to be here. Thank you.
Thank you, Mr. Luo. Mr. Yasumasa, CEO from Japan E5 Lab. Hi, Mr. Yasumasa.
Good evening, Marintec China. My name is I'm very pleased to be here. Thank you.
Thank you, Mr. Yasumasa. Well, the format of this webinar will be, firstly, Dr. Martin's presentation, about 20 minutes. Then, 20 minutes panel discussion. The final 20 minutes will be Q&A time from the audience. Please be informed that Q&A box on your screen is now ready to have your questions. Now let's welcome Dr. Martin for the UNICO presentation. Dr. Martin, welcome.
Good evening, ladies and gentlemen. This is the fourth revolution at sea, Chapter 2, Zero Carbon Emissions. And what I'd like to do in my presentation this evening is to cover basically four topics. First of all, I want to talk about the strategies for cutting CO2 emissions by 2050. The logic here is that we try to focus on not just getting there, but getting there in the best way, given the fact that we are not sure what will happen in certain areas by 2050. I'll then talk to you about the innovation scenarios 2020 to 2050, and these are based on a document I produced in May, which called Maritime Scenarios 2020 to 2050, and I'll quickly run you through the relevant parts of that. And then finally, ship technology. We'll look at the ship propulsion strategies, how you actually improve the propulsion of the ship and reduce its carbon intensity, hopefully getting towards the zero carbon ship by 2050. Secondly, the shipboard electrical systems, because they're an important part for the shipbuilder and the ship owner. They're an important stepping stone along the way. And thirdly, integrating functional controls on the ship. And then finally, I'll finish up with the conclusion. So that's my agenda for this, for the next few minutes. Let me start with the strategies for cutting carbon emissions. And there's four I want to mention. And they're not all necessarily technical in principle, but I think they are all involved with the technology we're discussing in this series of webinars. And step one is to transport less cargo. You might find that a strange thing to say in a business where, as shipping investors, we all want cargo to grow. But in fact, there's no benefit in building a ship and then using it to transport cargo, which the customers don't really appreciate. We don't get paid enough for it. So really, we have to look at all the cargo we transport and try to eliminate the cargo which is not adding value, is the phrase that an economist would use. That's the first step and is a very big part of my scenarios. The second step is to make the ships themselves more efficient and enable them to operate with less emissions. And that means better monitoring, lower speed, using bigger small ships, improved hull and surface, and onboard energy efficiency. And again, it covers a lot of different areas which are of great importance. Step three is to develop zero carbon fuels, because a lot of the things I'm talking about we can do with the existing fuels, but to really get to zero carbon emissions by merchant ships, we need to be burning fuel which does not emit carbon. And then finally, we need to develop the I-4 technology that we will need to do all of the first three steps. So that's my agenda. When we develop these strategies, we need to start by thinking about the emissions of the existing fleet. We have today 99,000 ships of 2 billion deadweight tons, and they were mostly built over the last 25 to 30 years, and they emit carbon using diesel engines and technical systems pretty much from the last generation. And so the challenge here is to retrofit as much technology as we can onto the existing fleet, because these ships have about 2/3 of their useful life to go. And so many of them are quite modern. And so we can focus on these modern ships and trying to make them as carbon efficient as possible. And that gives us quick results, which I know is something that IMO and our governments want us to do. The second thing is to use bigger small ships. The chart here shows you on the vertical axis the efficiency in grams of CO2 emissions per ton mile for container ships from 0 to 16,000 TEU. And as you can see, the saving you get by going from a very small container ship to a 2,000 TEU is very big indeed. And going from a 2,000 to a 4,000 TEU is also very helpful. And so we'll be hearing later in this seminar about China's zero carbon ship container ships being delivered at the moment. And that sort of short sea shipping is very effective and has big savings, much bigger savings per TEU than you would get if you just build a much bigger 22,000 TEU ship. The third point I want to make is that we need to develop strategy tailored to each market segment. And there are many different market segments in the merchant fleet, as you can see here. Bulk carriers and tankers, there's a very big tonnages, but cruise, ferries, offshore, tugs, dredgers, reefers, chemical tankers, vehicle carriers, liquid gas carriers. These are all areas where we can employ specialist expertise to get a much better result for that particular segment. And so we mustn't just focus on ships in general. We need to apply the technology to the job which each specialist ship has to do. If we move on now to the innovation scenarios, these are based on the 3 scenarios in my paper, Coronavirus, Climate Change and Smart Shipping, which was published by Sea Trade in May. And what I've done is to develop a series of scenarios that deal in the short term with the impact of the coronavirus campaign, and in the long term about how we can reduce carbon emissions across the merchant fleet. We start off, the first step is the trade scenarios. And if we take a look at these, I've got 3 trade scenarios. That shows billion tons of trade on this axis, from 0 to 25 billion tons. And scenario 1 shows trade dipping slightly in the next couple of years because of the coronavirus epidemic, and then expanding to 21.6 billion tons by 2050. The second scenario has a slightly worse recession in the short term, and trade grows to 15 billion tons in 2050. And the third scenario shows a deep dip. This is a more extended coronavirus recession, rather like the 1980s was, and then trade grows very slowly to 11.6 billion tons in 2050. And if we just focus in here, this shows you the different coronavirus views, and we really don't know which of these is going to develop. I think it's going to be next spring before we can see how the pandemic is growing across the world, whether it's coming under control and whether we get recurrences over the winter. And secondly, the challenge of different trade levels for 2050. And one of the big impacts on the amount of emissions the industry makes is how much cargo the world wants us to shift in 2050. And in fact, you can look at these on the slides when you see them afterwards, but this is the 3 trade scenarios. Now, some of you may be saying, how can we possibly slow down trade? Or why will trade slow down? And what to try and explain this, I've taken just scenario 2, the soft trade scenario, the middle one, and I've split it down into the commodity groups which I used in that projection. And you can see there's a million tons of sea trade on this axis, same as in the previous chart. But in this case, I've split it by type of vessel, by commodity group. And you'll see that fossil fuels, which is the bottom trade group, accounted for 40% of sea trade in 2020, but they're going to halve to under this scenario to 22% in 2050. This is all on the basis that the whole of the carbon arrangement, carbon philosophy is about reducing the use of fossil fuels. And so we assume that the oil trades decline steadily. We get growth in LNG, which gives us maybe a 20% benefit, 16 to 20%, and chemicals as well, and that takes us down to 22%. Containers will grow about 3.2%, and dry bulk by about 1%. So as you can see, different growth rates, and this helps you to focus on, if you're developing low carbon designs, these are the areas you might want to focus your attention on: the containers that will be growing, the LNG ships, the dry bulk, etc. I then went through a very long modeling exercise to produce 3 emissions scenarios for each of the 3 trade scenarios. And they are shown on this chart. The chart shows million tons of carbon emissions on the vertical axis, and the way the emissions develop through to 2050. And if we take scenario 1, what we see is that carbon emissions fall to 472 million tons of carbon emissions in 2050. And that is achieved by trading the fleet at 14 knots and by trade growing at 2% per annum and by introducing the new technology waves, as I've suggested, and that brings us down to 497 million tons. Scenario 2, we see that actually carbon falls much lower to 293 million tons by 2050. And that is achieved by slowing down to 12 knots, by growing trade at only 0.9% per annum, and by introducing the 3 waves of new technology. And so you see we're well inside the IMO target, well below the IMO target. And then finally, the third scenario, scenario 3, we actually reduce carbon emissions to 179 million tons in 2050. That compares with IMO's target of about 460 million tons. And that is achieved by 10 knots speed, slowing down trade growth to -0.1%, and developing the 3-wave technology. So these scenarios do show you that we can make very good progress. Now, I've mentioned the 3-wave technology for achieving these targets, and in this slide, I show you scenario 2, which involves soft trade growth and 12.2 knots speed. And in fact, what I've done is to develop the implementation of new technology in 3 different waves. Wave 1, what we're doing is taking diesel engines, which we know the technology very well. Most of the ships, nearly all the ships being delivered today are diesel ships. And for the coming decade, we focus on making those ships as carbon efficient as possible using a whole range of technologies I'll discuss in a moment. Then the second wave of technology is gas and hybrid, and we're starting that simultaneously with the diesel wave, and we're starting to develop ships which use LNG fuel or maybe LPG, and they use hybrid battery technology to improve the efficiency. They may also involve shore-based cold ironing when they're in harbour. And what's happening here is that we're developing this fleet of ships to peak around the late 2030s, and then they decline and are replaced, we hope, by a new generation of zero carbon ships, which are electric fuel cells using whatever carbons, whatever fuels are available, whether it's biofuels, hydrogen, ammonia, or maybe even nuclear power. You know, that is one that we know would do the job, but it's very expensive and has certain risks, as they all do. Okay, now we move on to the technology and the ship propulsion and the fuel that it uses. And when I look at the application of new technology to ship propulsion and fuel emissions, I like to split it into 2 parts. I think the first part you look at is moving towards zero carbon power supply on the ship. In other words, you're looking for a motor which burns a zero carbon fuel, or in some way it succeeds in generating energy without emitting carbon. We don't quite know what technology will bring us, but the propulsion plant is the first step. And the second step is reducing the power that the ship actually needs. there's many ways you can reduce the power requirement of the ship. You can redesign the hull. You look at concept ships like the NYK 2050 eco ship, and that looks very carefully at the hull in order to make that much more efficient. You look at better better coatings, bubble technology, better electrical systems, lots of things. I'll go through them in a minute. Let's just take a look at this. If we start with where we are today, I'm taking a typical bulk carrier, 64,000 tons, 13.5 knots speed, burns 22 tons per day of bunker oil. That's 129 grams per kilowatt hour, and it produces 7.3 megawatts. And one of the big decisions that we have, well, two of the big decisions that we have to make as we go forward is whether we switch from an internal combustion engine to burning LNG, LPG, methanol, ammonia, hydrogen, biofuels. All of these are being discussed. They're all in play. They all have strengths and weaknesses. And these are the fuels, and the power options we have are hybrid, that is diesel and battery, pure battery, fuel cell, wind power, solar, wave, and nuclear. These are the options that we have there. And the current fuel systems for diesel engines lose about half of the energy. They lose about 51% of the energy burnt in the engine is lost in heating the engine and exhaust emissions. And so obviously we can continue to work on reducing these losses and making the energy slightly more efficient, so you recover slightly more than 49.3% of shaft output. One of the ways of doing this is waste heat economizers, either on cooling or on principally on the exhaust gases, and that can generate electricity which goes into the electricity and battery system, or it goes into the propulsion system to reduce the energy required by the ship. The propulsion system actually takes the 49% of the shaft horsepower created by the diesel engine and reduces it to 28%, because we lose 15% in the propeller and the transmission. And again, we're looking at ways that we can cut propeller losses of 15% by a more efficient propeller, wake equalizers, pre-swirl, new propulsor. These are all things that people can look at. Very difficult to do. We've been working on these for a long time, but there's still possibilities. And indeed, you might go for a completely new system. Again, the NYK ship uses a flipper, which may be a peculiarity. It's a car carrier, and it might not be so easy on other ships, but that's a radically different sort of propulsor. But moving then to the operation of the ship, we take the 28% passed on to the propeller, and we reduce that to 16% due to wave making and air, weather, and resistance and so forth. And so we can look at ways of reducing that energy loss through speed, hull coatings, air lubrication, ballast-free design, and light materials, etc. And then finally, of course, there's operations. There's a slide here which goes into the characteristics of the zero carbon fuels. It lists heavy fuel oil, LNG, and LPG, which have modest savings. Methanol, ammonia, and hydrogen all can have low carbon emissions, but that's only if they're produced with zero carbon energy. And currently, that is not the case. Most of these are not zero carbon fuels because the ammonia is produced using a fossil fuel. So that's a hurdle that has to be overcome. I won't go into this slide because although it's very important, it would take me a long time to discuss it. So I'll just leave it for the time being. If we now move on to ship electrical systems, the purpose here is to optimize the electrical system so that we can get some direct savings out of this by bringing in batteries and solar and other sorts of electricity. But it's also an important framework for the ship of the future, which may very well be principally a fuel cell type of ship. So we have at the moment a fuel supply of 2 tons per day of diesel oil, and that goes through the system of medium speed engines, generators, AC or maybe DC distribution. Some people say that would be better, to the main switchboard, and then distributed to around the ship and to the machinery. There are various things we can do here. We can get a shaft drive from the main engine. We can install batteries to interplay with the main and emergency supplies of electricity, and we can bring in solar, wind, wave power, and they can go into the system, either into the batteries or into the current use of the ship. And finally, fuel cells in the future, burning the various zero carbon fuels, and they would fit straight into this framework. So the great thing about going down this route is you save carbon in the short term with some of the things you can do immediately, but it also, you built the framework for step 2, for the next wave of zero carbon propulsors. And finally, functional control systems of the ship. If we want to get to zero carbon emissions, we're going to probably have to control the ship much better and be much cleverer about the onboard efficiency. And there are 2 things here. One is the control area network. And the idea here is that we have 8 or 9 different systems on board the ship. And at the moment, the structured, the messaging between these systems is not structured in terms of a protocol like the CAN bus that they use in motor cars. And so the idea is we introduce a control area network, and that is operated under protocols which have yet to be agreed, but I believe one of the committees is looking at this. And the idea is that you develop your, say, navigation system, and you plug that straight into the backbone, which is designed for, it has an electronic control unit. Each of these has an electronic control unit, and it means that you can optimize the functional system, but it plugs into a standard electrical information system on the ship, which means, as a result of which, everything is integrated and very efficient, and all the information that we need to get can be collected and analyzed, and this information can be viewed on the ship, or equally importantly, it can be viewed by the Office on Land or by the regulators. Many ways of using this advance in the design of ships, and it is very well proven on land. The second step with this is that we introduce process control to manage all this complexity much more efficiently, possibly using a protocol process such as modular type package and MTP, which is again used very extensively on land for equally complex jobs like chemical plants. It's an enormous challenge, but I feel if we don't meet this challenge today and start to work towards meeting it, we will not be able to meet the goals that we need, that IMO needs us and our governments need us to do in the future. So this is a big step. Well, okay, in conclusion, let me just briefly summarize. Emission scenarios that I analyzed suggested that we could meet the IMO's 50% reduction in 2008 emissions by 2050, and in fact substantially surpass that with only a certain amount of reliance on zero carbon fuels. We can start by systematically retrofitting existing ships, and that gets us quick results and also helps us to get better information for planning the logistics and operation of shipping companies. We need to develop new generation of low emission designs around the diesel engine. That's the second step. It's something we can do today. We know the diesel engine very well indeed, and we can start to find ways right across the ship to optimize the performance using both digital technology and new technical innovations, of which there are many becoming available. A related topic is that LNG technology is very well known, and we start to use that as a fuel. It's still a fossil fuel, but we get maybe 15 to 20% savings right away. And if we put in hybrid battery powers, we can probably improve on that as well and use cold ironing. So I think this gas and hybrid vessel, just as the motor cars did, is a very productive way forward in learning how to move towards zero carbon propulsion, and the industry and the cargo owners hopefully will give a real focus to achieving this second wave of development. And then finally, as part of this, we improve ship performance with control area networks and process control, which are not, strictly speaking, carbon cutters in themselves, but what they do is they build the platform on which we will eventually build the true zero carbon ship. And all of this these are steps which will take us one step at a time along the way. And this is important because we just don't know whether a zero carbon fuel will be available in 5 or 10 years. And if it is available, whether we will be able to get access to it at an affordable cost for the marine engine industry. It looks as though it could be much, much more expensive. And whether in fact we'll be able to handle the distribution and set up a global distribution network for these green fuels. It all takes time. So I think we need to focus on doing the things we know we can do today, one step at a time, whilst preparing to do the things we can only do if we get the fuels we need to do them. And so I think we take the whole step progressively, and hopefully with the monitoring and control systems that the I4 revolution we discussed last time will bring, we will be able to work the miracles that we need to perform in order to make the world safe for our grandchildren. Thank you very much for your attention, and thank you for listening.
Thank you very much, Dr. Martin. Although the internet is not so stable, I think one possible reason is about global warming. That's why we should make joint effort to try to reduce carbon dioxide emission. And that is the topic of our webinar today. Well, thank you, Dr. Martin. Now, I think, may I suggest we start with Mr. Tom to comment on the presentation and views on the reduction carbon emission, then followed by Mr. Rowe, then Yasumasa. Okay?
Yes, well, thank you very much, Dr. Wang, and thank you, Martin, for a very interesting presentation, as always. As you know, we, and as you mentioned already, within the cruise segment, despite where we currently are in the difficult times that we're facing right now, we've already made a significant investment towards the use of electric propulsion. We've also spent a lot of time looking at mechanisms to allow for improvements in energy efficiency. And of course, we've invested heavily in the LNG piece, and the majority of our new builds right now in our company are with LNG fuel. And we do see a pathway for LNG, even with the challenges that we face around methane slip and the engine type that we currently have. For a variety of reasons, we have to have ships which are dual fuel, and that doesn't necessarily lend itself to the most efficient engine installation for LNG. But we do believe that the opportunities brought on by using a gaseous fuel with potential for biomethane and then synthetic methane in the future will be significant. But I do agree that, you know, the key elements are really through continuing to improve your efficiency on board. As you rightly say, we waste a lot of energy on our current plant. We've managed in our company to see a massive reduction in our footprint when we're in port. You know, 5-6 years ago, we might have had an average hotel load of approaching 10 megawatts. Today, that is now around 7 megawatts or less. So we've already seen a massive improvement. We spend a lot of effort today on looking at the pathway towards reducing the various different consumers on board, which an electrical system allows you very much to concentrate on. So no, I think as always, are very interesting. I'm not sure I always agree with everything you say, but that's nothing unusual, as you know. And I think it raises a lot of questions around what is the practical approach. You're aware that, or I think we're all aware that ammonia has a significant following within the maritime sector at the present time. But I think we've all been faced, and certainly one of the lessons we've learned from our foray into the LNG fueled vessels is that the support infrastructure that needs to be built to ensure there is a robust supply chain is still very challenging. And I do believe that there's perhaps not enough emphasis being placed on how we can then link ourselves to those other segments of industry where there will be that demand, and how we can leverage that scale. You've mentioned electrical shore electricity. That's clearly an opportunity for many, many countries and ports to develop zero emission in port scenarios. But there's a lot to be done, and perhaps to answer, well, we'll come to some of the other questions that Dr. Wang is asking us later on, I think so. But no, thank you very much, very interesting. And it'll be interesting to see which of the recovery scenarios are going to be the most opportune, shall we say.
Thanks, Tom. Yes, Mr. Lowe, do you have any comment on Martin's presentation?
Hi, Mr. Wang. And also, thank you, Mr. Martin. Very interesting presentation. Even the internet is not well connected, but we can see there is a lot of work. And for this zero emission or decarbonization, we have did a lot of researches on that one. We have LNG, and we have also other like lithium battery and methanol, DME, and also nowadays we focused on the hydrogen. Besides this one, also ammonia. There is a lot of noise from this public or from this international shipping areas. So all about this one with individual research, and finally we find out for the use of this energy, I think decarbonization is the result of what we want to get, but beneath the essential characteristics for the energy that is enrich the hydrogen. This is the way. So we keep in thinking of this way. This is the first. And the second, for the shipping, because that's an international running. So from the UN umbrella, we need to focused only on ship itself and let this well-to-tank to the nations, because later on there is a lot of measures between different nations. We can use that one, but for focus on this energy itself, the enrich of the hydrogen is the way. And so we can see nowadays what we can use the LNG, yes, with all this technology together to meet IMO 2030 should be no problems. But the way is how to meet the 2050, that it need to be go to the zero carbon emission. And hydrogen is the way, clearly, but nowadays the technology is not mature for the shipping. Ammonia, just Tom, you are in the cruise industry, so for the ammonia, that's a big challenge, especially for your business. The smells, strong smells for the clients is not good experience. So ammonia for the future, we can see that is a rich hydrogen carrier for the use, not directly. And to go to the future for the power instrument itself of power installations, we need to not only use the internal combustor, we need to change over maybe to the fuel cells. This Mr. Martin mentioned. So in generally say, it's the way what we can go to the future. And nowadays we have settled these reports. Maybe later on in next few months, we can publish these research reports. Thank you, Mr. Wang.
Thank you very much, Mr. Ro, from your observation and a suggestion. And also, Yasumasa, what is your observation and a comment on Dr. Martin's presentation?
Thank you very much, Dr. Martin. That is an impressive presentation. And for the beginning, please let me tell you about E5 Labo very, very shortly. E5 Labo was established by top leading shipping company, trading house, and shipbroker in Japan. We also established E5 Consortium and invited more top leading shippers in Japan, such as electric utility company and oil majors. And all our activity is to have secure a sustainable future of maritime industry by electric ship. What makes us unique is we involvement of shippers. Thanks to their participation, we cannot only make the ship, but also develop the project itself by strong support from our partners, including shippers. At the same time, we are building pure electric tanker at first. For now, we are also developing electric tugboat, ferry, and bulker as well. We have two key approaches to zero emission. Firstly, to increase number of pure electric ship for short distance. That is only for short distance. Whole project idea is beneficiary for each party, shippers, operators, and ship owners. Secondly, to increase number of hybrid electric ship for longer distance and large size. For now, personally speaking, I don't think hydrogen, ammonia, and also CCS are not realistic solution as zero emission approach for us. LNG is nonsense as zero emission approach. Hybrid electric ship with battery and generator is the most promising as of now. and also workable idea for shipbuilders and ships owners. That is the point. To answer the most realistic and workable idea is our task. Thank you very much.
Okay, thank you very much, Mr. Yasumasa. Yes, Dr. Martin, all these comments from our panelists, are you ready to give some response?
Yes, I'm a bit upset to discover that you couldn't hear me very well in the presentation. I've changed microphones. Can you hear me now, Dr. Wang?
Yes, very clear.
Unfortunately, you know, the computer, the system had cunningly switched microphones on me. And this is exactly the sort of thing that if I'm lucky, I'm not on a lee shore, you know, and it's only my microphone. And this is one of the typical problems you get with computer systems. Well, first of all, I mean, as far as Tom's concerned, I think it's really great to get some practical. I loved his figures he quoted about the saving that you'd made on port electricity, getting it down from 10 megawatts to 7 megawatts. I mean, this is serious saving, and it's something that's going on now, but it's not going on the vast majority, you know, of those 99,000 merchant ships. I don't know what percentage of those could take advantage of that. And so, I mean, in terms of my theme, that we must do what we can, and indeed, Yasumasa's theme, that we must do what we can do today. I think, you know, we do need to look very hard at what they call the low-hanging fruit. I don't know if you have this concept that you pick the low-hanging fruit first, the easy ones to get at. And I think this is good stuff. And we have a lot to learn from some companies. Mr. Lowe's comments focusing on fuels, I was sorry I didn't get a chance to run through the slide about the alternative fuels, Mr. Lowe, because although I do think, you know, there are, apart from the technical difficulties with carbon and ammonia, the problem is that if you don't produce them with biofuels or some zero carbon fuel, they are actually just as bad as diesel oil. And so, and I mean, you know, only a few percentage points of the world's energy are currently produced in biofuels. And I think that the shipping industry will be very lucky if we get to the front of the list for these zero carbon fuels, because power stations, steel plants, chemical plants. I mean, I was just reading the European Union's press release on their investment in hydrogen, and they don't mention shipping at all. They mention the steel industry and the chemical industry, and also they're not investing money, they're hoping other people will invest money. So I do think on that point, there's it's great to go on with this investment. It's very important, but we need to have some other things going on at the same time so that we are seen to be making progress in the next 3 or 4 years, you know. But that was great. And as far as the electric, Yasuma's electric tanker with diesel generators. I mean, again, this is a very good hybrid route where the shipbuilders are going to learn a lot about applying the technology. And I would say, that as an ex-shipbuilder many years ago now, what's most important in all of this is that the shipbuilders get a chance to learn how this technology works and to build it into the new generation of ships. I'm sorry, that's a rather long, Dr. Wang, that's a long response, but I think it's been fantastic to have this chance to discuss these things, you know.
Okay, thank you very much, Dr. Martin, for the answer. in the whole overall way. Now I think 20 minutes panel discussion is up. So I will turn to our audience. So to our dear audience, would you please raise your questions to the panel? In fact, we have got quite some questions from our audience. Well, the first one I will say, well, this question is for all. Superior Hall in companies, this question, has developed a very important innovation, which is in need of proper partners in our project. But we cannot get respectful interest. So people we contact ignore us. What can you do to help us reach the industrious respect and attention? Ammonia? Yes. Who will take this question?
I didn't quite.
Dr. Wang is Tom Strang. I was just wondering, I saw that, but I honestly, I wasn't able to find any details about their specific technology. Is there any more information that they can provide?
Yes. This question, let me see. Yes, to see whether it is possible for us to find some possible way to win respect or attention from interesting parties.
This, am I right in thinking, Dr. Wang, that the questioner is asking about hull designs, innovative hull designs?
Okay.
Is that correct? Is that what he's saying?
Yes, I think so.
Yes, because in fact he's asked a similar question at the last panel that we didn't get round to discussing, and like Tom, of course, I mean, the problem with all of this new technology is getting funding, and to do that, you either need to go to an international organization or a classification society, and people are a bit short of money at the moment, or you need a commercial case. And the difficulty with, especially with things like hull designs, is that it's such a complex business that developing a cash flow for a ship owner who adopted the innovative design might be a bit difficult. I know that's not a very good answer, and I did think quite a bit. I think it's something we need to discuss on a one-to-one basis, if you see what I mean. I don't know if you, Dr. Wang, have any thoughts on this one, because, you know, how we get people to look at truly innovative designs for hulls, you know?
Yes, it's very important because design is the first point to minimize power consumption. So we believe this is also a very important step towards low carbon emission. Okay, the next question is from CY Fan. The question is, an innovative design powered by hydrogen bunkers from CSSC was released with CCS AIP certificate. The vessel will be delivered at the end of 2021 and operate on Zhujiang River in China. This is also regarded as a part of Green Pearl River Plan in Guangdong Province. What do you think of this effort toward zero carbon? This question is from China. Who will take this?
Well, I could.
I think I trying to answer this one. So first of all, this is not a bunk barge, it's a small cargo ship, inland waterway cargo ship. Last Marintec, we announced together with CSSC to announce this project and give the design approval in principle. And this project is trying to test or trying to make a project like a pioneer or like how to say, demonstrate to the shipping, especially for the Chinese shipping industry to use or switch to this hydrogen. This is only one vessels trying to doing with this one, and the main power is PMFC with battery auxiliary powers. And total distance to serve is, what I remember, is around about 150 kilometers in Pure River. So this is what I can say, not for the commercial use, but the demonstrate for this use of this fuel with the hydrogen. And nowadays we divided in several parts of the total designs and the verification with the use and safety. Hopefully,
thank you very much.
Next year.
Okay. This is a very important effort from China, and also the China's contribution. This is a very worthwhile try. Okay, next question is, let me see, as leading international cruise line, Carnival has adopted LNG on Ida Nova, which is #1 in the world. Could you tell us more about this innovation? I think this question is for Tom, all right?
Thank you very much. So yes, it depends on how much. I'll try to keep my answer short. So it's been a very interesting journey for us in the cruise industry to move to a gas-fueled vessel. I think we clearly made these decisions before the current focus on decarbonization, and we really made the decisions looking at the IMO 2020 requirements and the reduction in NOx, SOx, and PM, which for a segment of the shipping industry like ours is really very important. Local air quality, local air emissions, and LNG ticks all of those boxes. It does give us an appreciable reduction in our carbon footprint, depending, of course, upon how you account for it, because of methane slip, because of, at the moment, we only are required to account for our direct emissions, not the upstream emissions that are part and parcel, but there's a much broader discussion to have there. But no, it's been a very interesting journey. I think when we started this, there were 2 LNG bunker vessels in the world. Now there are 9 and more coming, depending upon the rate that they come out of Singapore and China. There's something like 7 or 8 LNG bunker vessels on order at the moment. And clearly we see it as an important stepping stone. The challenge has been developing the supply chain. Prior to me joining Carnival 20 years ago, I was in Lloyd's Register as a surveyor, and prior to that in a shipyard. And LNG fueled vessels have been around for a very long time. And the technology is well understood. It allows us to use cryogenic materials, and we've found some very interesting opportunities to improve on efficiency and performance. So it's been but clearly we are limited by the number of locations where there are bunker ports available. And if you think, and this is what I always ask myself, if we think LNG, which has got a very well-developed infrastructure in place, and we try to then look forward to hydrogen, if we look forwards in our crystal balls to ammonia, then there's a massive effort that's going to be required to build a bunkering infrastructure. Today, around about 40% of the world's cruise ships that are on order with LNG as fuel. We've seen CMA, CGM, a number of other major ship owners transfer their allegiances to LNG as a potential fuel. And really at the moment, it's the only scalable fuel that has that kind of infrastructure to support it today. Does it deliver zero carbon? No, it doesn't. But it is, we've seen that the reductions are somewhere around 15 to 17%. We've innovated with the engine manufacturers to skip firing, all these things to manage the low load performance. But really the key has been developing the bunkering infrastructure and imagining how that's going to go in the future for these new novel fuels is really going to be perhaps the biggest challenge that people face. But no, it's been very successful. The ships are operating continuously on LNG. We have a great performance from them. And yeah, even though our ships are currently paused operationally, we're managing to, you know, which is a scenario we never expected to have to deal with. You know, we're managing the tank pressures well. We don't see any big issues. And no, it's, you know, touch wood, it's been a very, very successful integration. And of course, it does allow us in the future to think about other gaseous-based fuels or other cryogenic fuels. So we're learning an enormous amount.
Okay, thank you very much, Mr. Tom. Although LNG, you're right, is not really zero carbon emission, but it is a very important step. And also currently, it has been put into use. Okay, next question is from...
Sorry, Dr. Wang, just one final comment. And of course,
okay,
as I said previously, there's a pathway to zero emissions by the use of biofuels in the future. And I know a lot of people don't believe that there's going to be the quantity, but some of the recent studies that are coming out now would indicate that there's the potential for a lot more biomethane in the future than perhaps we've thought there would be. So it could be the solution.
Yes, thank you. Thank you for the answer. Well, the next question is from Katsutoshi. I think this is a Japanese audience. Well, the question is, in Martin's slide, what sort of light material do you expect to have? Can it be aluminum alloy, for example? Well, Dr. Martin?
Thank you. Well, that particular comment was largely based on the NYK Eco 2050 design, which uses a rather clever structure of for the hull and to produce a lightweight material. I have to say that shipbuilding is famous for being steel bashing, and I think getting on the sort of scale of international shipping, which to sort of pick up Tom's theme, that it's what you can do in one concept ship, is very different from what you might do for 90,000 ships around the world. I think that probably in the beginning, perhaps using more high tensile steel. I mean, I noticed that bulk carrier that I used in my fuel slide had over 80% of high tensile steel, which does reduce your weight significantly, but also perhaps using some aluminium and so forth. It's not a big issue, I think, but it's something you can technically look at, and I'm sure technologists will find solutions. You know.
Okay, thanks, Dr. Martin. Well, next question is also from our audience. Hydrogen energy is regarded as the most competitive energy in the future. However, it is expected to put into wide use in 2050. Do you have any different prediction, and what effective steps should be taken to short this period? Who will take this? Yasumasa?
Okay.
Do you have any comment on this?
Yeah, okay. To be honest, I'm very skeptical for using hydrogen for the ship's fuel in the future, because I don't think hydrogen is realistic ship's fuel in the future, and it won't be one of the main energy sources at 2050 for the ship. We learned many things from our hydrogen-powered tugboat project. Through the experience of that project, we realized that usage of hydrogen itself as ship's fuel has crucial difficulties, which I think there's no fundamental solution. The difficulties are, as Tom explained, bunkering. That is very, very difficult for hydrogen, and also storage and supply system. Also low efficiency as energy itself, and handling risk as material. Considering those points, I would say that usage of hydrogen as ship's fuel is quite unpromising, since there's many difficulties have to be overcome technically, and how to reduce the cost is also one of the big challenges for hydrogen. My conclusion is the best way of utilization of hydrogen energy is massive production, massive transportation, and massive consumption. That's my opinion for hydrogen fuel in maritime sector.
Okay, thank you very much, Mr.
I think,
Yasumasa.
Dr. Wang, could I just make a little comment there?
Oh, wait, excuse me, Dr. Martin. Well, timing is nearly up. Well, may I suggest we will extend 10 or 15 minutes so that more questions could be asked. Dr. Martin, Yasumasa?
Yeah, oh, thank you. I think, you know, the problem, the benefit of doing scenarios of the sort I did is that you have to put something into the scenario going forwards. And you know, the problem with not using, the problem is that we don't have a zero carbon fuel. I mean, everything that Tom says is fine, but it doesn't, but LNG doesn't take us to zero carbon. He's suggested that there might be a magic solution from biofuels. But when I look at the world energy supply, you know, 40% of the world's electricity is still produced from coal. And, you know, there are a lot of very energy intensive land-based operations, which I think would be higher in the list for the sort of capacity, so for zero carbon fuels, and they are very, very expensive. So I mean, I think to some extent I put hydrogen and ammonia into the sort of scenarios because it's a possibility, and it is a possibility. But I think we have to hope that we will find, you know, some magic new way of doing this, which just like we hope we will find a coronavirus vaccination, you know, it's something that we can't be sure of till it arrives. And I don't think it matters, because if your strategy is to focus on doing the things you can do today as quickly and as well as you can, then what my scenarios show is we can get 3/4 of the way to zero carbon just doing those things, you know.
Okay, thanks, Dr. Martin, for the important supplement. Okay, our next question is from Giulio. I'm not so sure which country is from. The question is, IMO 2050 scenario considers direct GHG emission only, therefore neglecting the bulk of indirect GHG emissions and all non-climate change related externalities. Due to such partial approach by IMO, the industry might risk pursuing solutions that address compliance rather than the actual goal. I would like to know the comments of the panelists on this issue. Who will take this question first? That is a little comprehensive question.
I guess this is the famous well to wake scenario, which says that you should measure everything properly. And I mean, IMO's problem is that we're still struggling to measure simple things like bunker consumption. I mean, it's only, we still don't have a verifiable figure for the actual bunker production of the world shipping fleet, because it's, you know, it is actually based on the purchase of bunkers, not on statistics for the emissions by the ship. So I think there is a very long way to go before we can actually implement a well-to-wake type of tracking strategy. And once you can monitor things, then of course you can focus. And we get back to the issues we just discussed about whether we can find a fuel which is zero carbon well to wake, you know. And I raised the issue that that's difficult for hydrogen and ammonia, and it may, you know, and Thomas suggested that there may be a possibility of some way producing vast quantities of biofuels, which I hadn't heard about. Maybe he has more information about that. But are there some well-to-wake zero carbon fuels that we're missing?
Maybe I can just jump in, Dr. Wang. I think this is a very topical issue, as you know. There's been a massive amount of debate at the IMO as to how one should do this, because if you look at the different proposals that are on the table today in relation to how we account for the carbon intensity, and if we do want to go down and look at carbon intensity indicators in the future, you could make a decision today based upon ammonia, which is made from LNG through a process where there could potentially a massive amount of carbon emissions upstream. Some of the production fields that you have for LNG have far lower carbon emissions than others do. There's a massive debate still ongoing as to what is the upstream emissions related to some of the conventional fossil fuels still today. But I don't think we can ignore that, you know, because you could lock yourself into a pathway that relies upon a technology which is very carbon intensive. And I saw on your questions that, you know, there's this whole debate about material use and shipbuilders when we're designing vessels. You know, we all believe lightweight technology will help us in the future, but if the intensity of actually manufacturing that is far higher, then are we actually, in a holistic way, improving the situation or not? So it is something I think we as responsible ship operators and owners have to take into account. And we have to see the IMO come up with a solution for this. And we've submitted papers through the different industry groups saying that, you know, when you do this, to allow certainty to ship owners to make decisions, you need to know how we're going to be measured, or how our performance is going to be measured in the future.
Yes, this is a very comprehensive work, which also needs joint effort by all parties. Okay, the next question is from, let me see, Shusuki. Perhaps this is a Japanese audience. Do you think the carbon capture technology plays any role in the reduction of vessel carbon dioxide emissions? Who will give some answer to this? Well, excuse me, Yasumasa, you should turn on your audio. And yes, right. Yes, who will take this question first?
It's a difficult one, isn't it? Because I have discussed it with various people, but nobody has ever left me more knowledgeable at the end of the discussion. I mean, it's a big challenge. My assumption is that it's something that, although ships have big engines, they're relatively small plants generally, and it's something that's going to be quite difficult to do on board the ship. But I'm afraid I can't answer any more than that.
All I can say, Dr. Wang, is that the few companies that have approached us in the past have not convinced us yet that there's a mature enough technology that is viable for installation on board as Dr. Lau Xiaofeng mentioned, a demonstrator yet. So that, you know, we need to see something that works before we're prepared, in the commercial world at least, to start making investments in that technology.
Okay, thank you. Well, next question is, the first electric E5 oil tank is expected to be delivered on March 2022. What's the characteristics of this vessel, and what is the expected output?
Maybe that question to me.
Yeah, I think so.
So, the number of Japanese domestic ships are currently 7,000 to 8,000 for now. And 70% of them, approx 5,000 ships, have to be replaced in 10 years. So you can imagine 5,000 ships have to be replaced in 10 years. It's a massive amount. We must be replaced in 10 years. So present domestic ships are adapted by very conservative power plant system. And that is why twice number of crews are onboarding the ship compared to same size ship in Europe. But we can assure you that our electric ship will achieve greater efficiency of ship's operation, say twice of present, which means number of crew would be just half of present. That's our target, and we are pretty sure it can be achieved in the soon future. Also,
we wish you success.
Yeah. So also life cycle cost of one Japanese seaman is about $3 million US. That's for life cycle cost. The saved cost is resulting of decreasing number of crew by our electric ship will be utilized for upgrading the ship. The key components such as electric system, battery system will be essential for upgrading ships. In this field, Japanese suppliers is far behind of overseas suppliers, and it causes of negative impact on industrial innovation and the ship built in Japan. Shipbuilding industry in Japan barely accepted overseas supplier in the past. However, we will lead and help overseas suppliers such as Europe and China to Japanese market. Our role is to connect Japanese high quality of shipbuilding and overseas suppliers advanced technology and machinery. It will make good synergy and bring Japanese market valuable ships in terms of environment, efficiency, and price in the future. It's our mission to achieve environmental and business sustainability for Japanese ship industry in the future. That's our task for developing this project. Thank you.
Okay, thank you very much for your effort from E5 lab. Okay. Next question is, I think it's from China. It is reported that on May 15 this year, an autonomous 300 TEU was started to build and will be delivered on the second half of next year. What do you think of this event toward zero carbon? I think this question is for Mr. Luo. Yes, Mr. Luo?
Oh, yeah. Hi. Yeah. I think this question should be in the last course or debate is for autonomous ships. But anyway, we talking about just all the guests talking about this new energies and also this electric and electric powers. What I think for the electric power, the benefits is not only for the future power units, but also for the autonomous or controlled. So there can be units in the future for the autonomous ship. And with the zero carbon emission technology, with requirements, this technology can be used too.
Okay. Thank you very much, Mr. Luo. Well, time is nearly up. I have to make a very short concluding remark. Well, this is a very fascinating dialogue. Thank you all for joining the panel. And may I invite you to join me to thank Dr. Martin Stoffel, Tom Strong, Mr. Rou Xiaofeng, and Mr. Yasumasa for their excellent sharing. I do hope that today's webinar is most insightful to you all. The next chapter of Marintec Innovation Web series will be held on 3rd September. It's about advanced digital system. This is particularly important from Martin's unstable signal. The keynote speaker will also be Dr. Martin. Please scan the QR code for registration. Your feedback to this webinar is highly appreciated. Thank you all for joining us today. Wish you all safe and healthy. Looking forward to seeing you again next time. Goodbye. Bye-bye all.
Okay.